cars and Tesla puts out pretty high. If I put it on, it gives me a little reading. It's just, it should be zero. It's electromagnetic forces that come up that can affect your health, cause cancer. So I'm here now. I always measure this. And on the old EV1 that General Motors made, it was horrible. You drive along, I had this on my lap, and the electromagnetic force, if you look up in Sweden, they have a TOC standard for electromagnetic. They're one of the few countries that does. Anything over 2 milligauss is bad. And when you walk under power lines, sometimes you're 50, 100 milligauss, and you're walking under them, you're walking under them for quite a ways over in Gilbert, Freestone Park. And if you're riding an electric car, you're riding along for an hour or two. And then a Tesla Roadster, right behind you is where the motor is, and it's real high, 10 to 20 milligauss or higher as you're driving along. If you measure it on the newer cars, like my Ford or the Soul we have, or the new Tesla S, there's almost nothing. And that's why I wonder with this bus, there's 2 electric motors in the back here. I'm wondering how much this might put off. So I'm just gonna, so far I'm not seeing much. I'm going to measure it to see if there's anything.
Mas tem os que tem no chão, uns caminhos quadrados. Então, aquele lá ele tem uma chapa
I charged up the other day, and it told me I could go 125 miles, and the estimated range for the full charge. I usually only half charge it this time. My phone, things like brand new.
The Kia is brand new.
Brand new. You already read it, right? Oh, we gotta get a picture with the bus in the background so we can see the sign and we know we're at Bioshere.
We're well, this is silly. It's not really that silly. You finally made it here.
Yeah, it's real.
Okay, this is Biosphere 2 because Biosphere 1 is planet Earth.
All right, that's a good one.
Okay.
Wow, you learned a lot. Okay, let's go.
And that's what Dr. Hui was going to make his whole building covered with solar panels like that would run itself. And he couldn't even make one panel that would work on his house.
Yes, but it was a lotus. It was like a lotus flower.
Oh, yes. That dies, and you throw it out. Oh, well.
Still didn't put his seat back in his car.
No, he probably won't.
Not the airlock.
Not yet.
Now that's a real airlock there. Yeah.
All of them English. Got layers.
And it's going to be a great day. It's beautiful up here today, and we have a group of interns from Brazil. They are interns at ASU, and they're engineers studying sustainability. So you may notice my other visitors I have. So I'm really glad you're here because you're going to help change the world, and that's wonderful. And our scientist, Dr. Jos van Haren, has been to Brazil, and he's a rainforest scientist. So you'll see our rainforest that he works in. He's been here for over 20 years now, Dr. Jos van Haren. So he's our rainforest scientist, and he's always studying all kinds of things in the rainforest. So thanks for visiting us. And I'm going to start the movie, and as we go along, then I'll tell you where we are. But right now we're underneath that little white dome you saw when you drove up. You saw a little white dome, and you saw a step pyramid made of glass. That's where the rainforest is. Right now we're underneath the little white dome, and the little white dome was their library. They had their books up there. It was their lookout tower. Now we open it up for nights that are special events, usually when it's cool in the fall or springtime. But you can look through the floor when you come back to the upper area upstairs. There's a lot to see upstairs. This is the lower habitat. This was their little micro city. Their farmland was over there with the African pygmy goats, wild pigs, tropical chickens, where our tour guide lounge is now. And that was their barnyard, actually. The farmland is where our Leo slopes are. And you might have seen the video of them farming, all the big cabbages. So there's a video out there showing some big cabbages and the Biospherians farming. They had a 1/2 acre farmland area right there when we step out underneath the Leo slopes. Now we have our big water cycle studies, the hill slopes, artificial hill slopes, to study how water flows downhill, how it stays in the soil, how fast it will evaporate out. So we're going to study the water cycle extensively with our Landscape Evolution Observatory hill slopes. Then we're going to go into where the glass pyramid is, and that's the wilderness biome. So there are two sections. So if you just look on the very front of your brochure, you'll see where the tiny little white dome is. We're underneath that. Remember to go back upstairs where the door 7 is. There's a lot to see. Top of Leo or Leo exhibit, climate study. We'll have you can see a giant Tyrannosaurus Rex skull. It's a model of a giant Tyrannosaurus Rex skull. Climate study, and our lunar greenhouse exhibit as well, with plants in it, vegetables, sweet potatoes and cowpeas, strawberries, lettuces. And you'll see the apartment that you can view into, the model of the apartment. The last Biospherian lived in there, Bernd Zabel. He was in the second group. And you'll see the kitchen. So remember door 7, that's when you can walk around. That's upstairs. You came down to door 8. All you have to do is then walk around the rainforest, look in. You may see banana bunches. Look in, and then come all the way around to door 7. I'll give you more instructions. So if you look at the very first
The University of Arizona College of Science and the researchers and staff of Bioshere 2 welcome you to the world's largest experiment in environmental science. Bioshere 2 operates as a unique collaboration between public and private sectors, and researchers collaborate across disciplines working toward a common goal of understanding. This $150 million privately financed facility was built in the mid-1980s It is now owned by the University of Arizona and is a department within the College of Science. Established in the late 19th century, the University of Arizona is a land-grant institution dedicated to building a better world. And that's what Biosphere 2 is all about. It's a test site, a patch of Earth under glass that will give us new understanding of Biosphere 1, our world.
I'm Carolyn Porco, and as a planetary astronomer, I have spent my entire career exploring the outer solar system. Most recently as the leader of the imaging team on the Cassini spacecraft presently in orbit around Saturn. We've learned a great deal from Cassini about the physical and chemical processes that make planets work, and we have seen some spectacular sights. Intricate and dynamic structures within the rings of Saturn. Towering fountains of icy crystals on the small moon Enceladus, and seas of liquid methane on Saturn's largest moon, Titan. But what we really gained from the examination of other worlds is perspective. A recognition that our planet is small, isolated, and vulnerable, but also precious and, at least in our solar system, completely unique. Living organisms arose on this Earth more than 3 billion years ago. They've survived and evolved because of a steady abundance of life's main requirements: energy, organic matter, and liquid water. And we find these organisms thriving across an enormous range of environmental conditions. Take plants, for example. They can grow in a variety of soils and temperatures and climates, but by their very existence can also influence those factors. And this remarkable facility here at Biosphere 2 allows scientists to examine and isolate thread by thread the complex web of life. It may look like a giant greenhouse, but don't be fooled. It's no ordinary plant nursery. When you enter Biosphere 2 in the next few minutes, you'll see 5 different biomes or unique communities of plants living under different regional climatic conditions. Ocean, tropical rainforest, savanna, marsh, and desert. Here is a sophisticated scientific instrument that permits us to control and measure nearly every important environmental factor contributing to these ecosystems. And we can do it here in a very big way. Because of its enormous size, Biosphere 2 can support these natural systems on a close to real-world scale. Each of these plant communities is carefully maintained by regulating soil, temperatures, and the big one, the presence or absence of water. In fact, water is the main focus of Biosphere 2 research.
The biosphere is an instrument where the grand challenges of science today with respect to the environment can be studied in all kinds of detail, and detail that nowhere else can be done. We still don't understand the mass balance of water in semi-arid environments. Now, what's the mass balance of water? What I mean by that is how much water is going to go into the aquifer, how much water is going to run off, how much erosion is going to occur. Importantly, for example, in the Southwest, 25% of the humidity that we have, which controls our weather, comes from evapotranspiration of plants. So you can just see the cycle. And nobody actually knows exactly. We know it in very broad strokes, just like I mentioned it right now, what that cycle is. But nobody has been able to quantify what that cycle really does.
This big environmental chamber is uniquely suited to explore complicated questions about climate change.
The first and most important experiments that were ever done by anybody on that particular question was done exactly here at the Biosphere, where they sealed the doors, they cranked up the CO2, and they saw what happened to the ocean as CO2 went up, and the ocean acidified, and the corals started suffering. But nobody actually knew how much CO2 it would take to do that. We can write equations. The equations that we write are pretty simple compared to the complexity of all the systems and the feedback mechanisms of plants and everything else. So you really have to do experiments. but the experiment that the University of Arizona specifically created to be in the biosphere is the Landscape Evolution Observatory that is going to address what happens to water in semi-arid environments as vegetation changes, as global climate change progresses.
When the University of Arizona took over operation of Biosphere 2 in 2007, they realized that this space here was underutilized. This area we're standing in, and that now houses the Landscape Evolution Observatory, was the former agricultural biome for the Biospherians during the original human habitation mission. The transformation of this facility represents the first complete repurposing of a space here in Biosphere 2 for the new scientific mission led by the University of Arizona. The University of Arizona organized a planning process that involved local scientists and also scientists from many different disciplines of study and different universities and organizations across the country. The philosophy behind the Landscape Evolution Observatory was to develop a unique tool to help us to better understand the way landscapes function. What I mean is the way landscapes cycle water, carbon, and energy. These processes within landscapes are also critical for human beings, especially in arid environments like the southwestern United States. The water that we rely on for drinking and the purity of that water is ultimately controlled by landscapes, the way they filter precipitation as it flows through the subsurface and ultimately into our aquifers and streams. These landscapes span 330 square meters of surface area and include more than 1 million pounds of soil, with topography like we observe in natural landscapes. As such, the Landscape Evolution Observatory is an entirely unique experimental facility because of the control we have here over climate variables, much like you might have on a benchtop in a lab. But beyond that, also because of the enormous size of these hill slopes, we're able to capture a lot of the complexity that happens in nature with these large landscapes, but again, under the same type of experimental control that you would have working at a much smaller scale on a benchtop in a laboratory.
Trying to simulate and control Earth's complex life systems was in part a founding principle behind the initial Biosphere 2 experiment. The Biospherians lived here, and they worked up there in the various biomes where they conducted experiments and monitored something like 4,000 species of plants, amounting to 20 tons of living biomass. But this highly publicized experiment eventually hit a wall. Next question, yes. What the public saw was a failed experiment, but scientists saw no such thing.
So we were never deficient in nutrients. However, we were very low in calories.
Jane Pointer is a former Biospherian.
It was an incredible success. I mean, it was an engineering triumph. I bring people around Biosphere 2 all the time who really were a little unsure about the project. And once I've walked them through and they really see the incredible engineering that went into it, the science, what was involved in designing Biosphere 2, I mean, they're flabbergasted at what we managed to accomplish here.
Scientists learned a lot from the Biospherian era, and since then they've used Biosphere 2 to conduct a variety of experiments. All these successes and failures have provided valuable insights into the processes governing natural systems. At the end of the day, Biosphere 2 has become an irreplaceable, one-of-a-kind tool for researchers eager to learn how our planet works.
The size of this chamber creates its own challenges, like high utility bills, the technology, and I sure wouldn't want to be the one having to wash these windows, though the rain right now seems to be doing a pretty good job of it. But Biosphere 2 has the capacity to address very large and complicated questions in the earth sciences, and so the ultimate payoff is very big.
It's not just the scientists who get to ask questions here. Biosphere 2 is dedicated to inquiry on all levels. Biosphere 2 is a learning center for tomorrow's scientists and a conference center for today's leading researchers. And this remarkable facility offers outreach activities, special lectures, and art exhibits, all aimed at improving science literacy in the 21st century.
We have 100,000 visitors that come to Biosphere 2 each year.
And it's a fantastic opportunity to talk to them about the importance of science generally and about the specific findings of the research that we do here at Biosphere 2. So of those 100,000 visitors, about 10,000 are K-12 school children, and they come with their classes and their teachers, and they take tours, they learn about the research that we're doing, they learn about the environment. We have curriculum and various topics and subjects that we engage them in, either for a couple of hours or even a whole day. In the summer, we have various programs where students will live on site for up to a week at a time doing research. And we have our Summer Science Academy, which is very successful with middle and high school students on site. We have partnerships with other organizations around the country and around the world to bring students here for various amounts of time.
So welcome to Biosphere 2, one of the biggest and most complex scientific instruments aimed at understanding our environment that you are likely to see anywhere ever. And as you wander under the glass, keep in mind that it's all meant to understand more about Biosphere 1, our fragile blue ocean-covered planet Earth. We live on a unique and astonishing planet, and the better we understand it, the more likely it is that we will leave it healthy and robust for future generations.
Wild pigs and tropical chickens. No beef for 2 years. Can you imagine sitting up in the dome and watching? This is a cattle ranch. Watching all the little cows roam around. Where's the beef?
Waving at us, we're going the other way.
So you're going to see bamboo, and the bamboo wall was the only dividing wall protecting the rainforest from the salty ocean spray. So the bamboo wall, there's a green bamboo, yellow bamboo, and a little green bamboo. So did everyone give in every fish? And then you put plants, because in each of these areas, the basalt, the plants can grow there. You can grow vegetables. And this is a good way of recycling, being a self-sustaining recycling way of watering. So does anyone know about aquaponics? So you can recycle water, and it's a way of, we all need water, plants need water, and the fish need water. The fish actually provide nutrients. Their waste actually fertilizes the plants. And then the plants actually clean up the water. So it's just amazing, this connection. And the microbes that live in the little cracks of the basalt, there are a lot of little microbes that can live in the little cracks of basalt because it has a lot of surface area. The cracks are just all over. It's a volcanic rock. And so you see in the future something's going to happen here. And I'm really excited because they've been sitting out and nothing had been happening, but now something is. So this is our area where we can change exhibits and areas of study. So there to make the hot water during the winter. Cooling towers that you'll see on the outside when you're walking around those cooling towers cool down the water. So it's a closed loop system. A fan blows across. There's a heat exchange that occurs. The air comes out cold like today, or hot in the winter time. They drank the condensate out of the small air handlers. So they had small air handlers, and they drank the condensate they would collect. It was pure enough for them to drink when they lived inside. They recycled their water, like pumped up the water. You see pumps in the south lawn by the water reservoir, and they pump the water back to be the rainfall. And you might have noticed sprinklers. However, it was so humid inside everywhere because they were a tropical, subtropical environment. They had very, very huge levels of humidity. Then overnight, when the air glass would cool down, just like your glass can condensate, there'd be a lot of condensate in the morning too. And that happens in the winter here, even though it's an open system. So let's peek this way, and I'll drop you off here. And then I'll tell you all how to get there. That's the whole. Yeah.
We're gonna suffocate. A few people survive.
I was on this ride in Disneyland.
Biosphere 2. We just came out of the heart and soul of Biosphere 2, the technosphere, all those air handlers. So back in the day, that's where they controlled the climates, and still it happens over there, the energy center. Our technicians are here 24/7. They know when we're...
And there could be...
Foto.
Para que se vea esta pelota.
Todos. Sí, vengan. Foto. Photo. Foto.
How do you translate that?
Huh?
The mountain in the back.
Yeah, come on guys.
You gotta get to the dome in the back.
Come on guys.
Working with scientists, engineers, artists, and experience
And on the inside, I have a deflector that keeps the heat out.